Chapter 4, Strong Acid, Strong Base, Class Life Sciences. Part 5, Strong Base. At the end of this session, students should be able to define strong base, specify the characteristics of strong base. Part 7 of Chapter 4, Strong Base. Definition. Solid sodium hydroxide NaOH in solid state is dissolved in water and it ionizes completely. Then sodium hydroxide is a strong base. We will study different solutions of sodium hydroxide, and from this study we will deduce the definition and the characteristics of strong base. The table below shows different sodium hydroxide solutions and the pH of each one. We will complete this table by calculating the concentration of H2O plus in mole per liter, which is equal to 10 negative pH. For first solution, 10 negative 11.7, which equal to 2 10 negative 12. Second solution, 10 negative 11. Third solution, 10 to the power negative 10.7, which equal to 2 10 11, 10 negative 11. And third is 10 negative 10 mole per liter. Now we will complete the table by calculating concentration of HO minus, which equal to 10 negative 14 over concentration of H3O plus. Since our study is at 25 degrees, then Kw equal 10 negative 14. In this case, 10 negative 14 over 2 10 negative 12 equals 5 10 negative 3. 10 negative 14 over 10 negative 11 equals 10 negative 3. 10 negative 14 over 2 10 negative 11 equal 5 10 negative 4. And 10 negative 14 over 10 negative 10 equal 1 10 negative 4. Then, for each solution, we have concentration of the base Cb and concentration of HO minus. We will study the second solution where concentration of a base equals 1 10 negative 3 and concentration of HO minus also equal 1 10 negative 3. Let's study the sodium hydroxide solution of Cb equal 1 10 negative 3 mole per liter. The equation of ionization of NaOH in water, it gives Na plus HO minus. At T equals 0, when sodium hydroxide is completely dissolved in water, consider it at T equals 0 before it ionizes. The concentration of NaOH dissolved equal 1 10 negative 3 mole per liter. Before the ionization, 0 0 for Na plus and HO minus. A variation, NaOH ionizes by amount X, the Na plus and HO minus formed amount equal to X. Then at the end of the reaction, it remains from NaOH non-ionized 1 10 negative 3 minus X, and the formed of Na plus and HO minus equal to X. X is the concentration of HO minus at the end of the reaction, which equal to 1 10 negative 3 for the second solution. Then 1 10 negative 3 minus 1 10 negative 3 equals 0. 1 10 negative 3 for Na plus and 1 10 negative 3 for HO minus. Then NaOH has completely ionized in water. Conclusion, NaOH ionizes completely in water. Now we can deduce the definition of a strong base, since NaOH is a strong base and the NaOH is completely ionized. Then a strong base is the base that ionizes completely in water. Any base that ionizes completely in water is a strong base. The general equation of ionization of strong base, strong mono base, is BOH is the general representation of strong mono base. BOH, in presence of water, it's ionized into B plus cation and HO minus. For example, sodium hydroxide solution ionized into NaOH ionized into Na plus and HO minus. Potassium hydroxide KOH into a K plus and HO minus. Now, characteristics of a strong base. Based on this table, we will deduce the characteristics of a strong base. For each solution, if we compare the concentration of the base and to the concentration of HO minus, we find that they are equal. Then we can deduce that a strong base is characterized by concentration of HO minus equal Cb. Concentration of HO minus 5 to negative 3 equal Cb, 5 to negative 3, 1 to negative 3 equal 1 to negative 3, and so on. Then, when the concentration of HO minus equals Cb, then the base is a strong base. Now, since pH equal negative log concentration HO plus and concentration of H3O plus equal 10 negative 14 over concentration of HO minus, then the relation becomes, and H3O plus equal Kw over concentration HO minus, Kw over Cb, HO minus equal to Cb, then we can replace HO minus by Cb, Kw equal 10 negative 14, then pH equal negative log Kw over Cb equal negative log A over B equal log A minus log B, which is Cb, equal negative log Kw minus times minus equal plus log Cb. Negative log Kw equal pKw plus log Cb. Then pH of a strong base equal pKw plus log Cb. At 25 degree equal 14 plus log Cb. At 25 degree pKw equal 14, then pH equal 14 plus log Cb. Therefore, pH equal 14 plus log Cb, because our study is limited at 25 degree. The third characteristic, upon dilution from 510 negative 3 to 510 negative 4, 10 times dilution, and from 110 negative 3 to 110 negative 4, also 10 times dilution, the pH decreases from 11.7 to 10.7, decreases 1 unit, and from 11 to 10 also decreases 1 unit. Then we can deduce after dilution 10 times, the pH of a strong base decreases 1 unit. Also upon dilution 100 times, it decreases 2 units. Upon dilution 10 power n times, it decreases n unit, the pH. Application 8. Consider a solution of potassium hydroxide KOH of Cb equal 10 negative 3 mole per liter. The pH of this solution is 11. Show that potassium hydroxide is a strong base. 2. We dilute this solution 100 times, determine the pH of the obtained solution. Solution of application 8. Part 1, we have a KOH solution of Cb equal 10 negative 3 mole per liter and pH equal 11. Then we dilute this solution 100 times to obtain solution S prime, this solution S, of C prime B and pH prime. Part 1, from pH and CB, we have two methods to show that KOH is a strong base. First method, from pH, we calculate concentration of H3O plus, then we calculate concentration of HO minus. H3O plus equal 10 negative pH equal 10 negative 11 mole per liter. Then concentration of HO minus equal 10 negative 14 over concentration H3O plus equal 10 negative 14 over 10 negative 11 equal 10 negative 3 mole per liter. If we compare concentration of HO minus with the concentration of the base CB, they are equal, then we can deduce concentration of HO minus equal CB, therefore KOH is a strong base. Other method, we calculate 14 plus log CB and we compare it with pH. 14 plus log CB equal 14 plus log 10 negative 3 equal 14 minus 3 equal 11. 11 is pH, then pH equal 14 plus log CB, therefore KOH is a strong base. This is part 1. Part 2, in order to calculate pH prime, we should calculate C prime B. After dilution, we have dilution 100 times. Number of mole of solute is conserved. That means F equal CB over C prime B equal 100. Therefore, C prime B equal CB over 100 equal 10 negative 3 over 100 equal 10 negative 5 mole per liter. Then pH prime equal 14 plus log C prime B equal 14 plus log 10 negative 5 equal 14 minus 5 equal 9. It decreases from 11 to 9, it decreases 2 units upon dilution 100 times. Other method, this method is used when we are not given CB to deduce C prime B, but we are given pH and F. From pH and F we can deduce pH prime. How? Then upon dilution, CB equal C prime B equals CB over 100 over F. pH prime equal 14 plus log C prime B. We replace C prime B by CB over 100 over F equal 14 plus log CB minus log 100 equal 14 plus log CB is pH of the initial solution minus 2 log 100 equal 2. Then pH minus 2. pH is 11 minus 2 equal 9. Then if we are not given CB and C prime B, we can deduce pH from F and the old pH. This is the end of part 5 of chapter 4, strong base.